I'm not sure whether you are aware of it, but there is a war going on right now. I mean, this is not a war between countries, and there are no agendas involved, and not even other people. I'm talking about a very personal war that each one and one of you is deeply engaged in. Not against others, but rather against yourselves. In the middle, wearing a yellow costume, I would like to introduce you to your enemy. This is a traitor that tries to take over your body. This is a cancer cell, a cell of our own that that no longer obeys the rules of our body. Around it in light blue, you can see our champions, our defenders. These are the lymphocytes, the cells of the immune system that won't let this traitor to escape. Can you see how the lymphocyte reaches out and grabs the cancer cell? I mean, this is pretty amazing, at least in my opinion. Well, how comes that all of us are engaged in war with cancer? Well, actually, normal cells in our body continuously become cancerous all the time. But it is our immune system that protects us and eliminates them. However, in rare occasions, cancer cells may become slightly resistant to the immune system. And this could trigger a dangerous race of arms because the immune system adapts to these cancer cells in an attempt to eliminate them. But at the same time, it increases the selective pressure on them to become even more resistant in response. So this means that at that time point, cancer is in fact present in our body. But it is kept under immunological control, so we don't even know about it. Eventually, the cancer cells become fully resistant and escape the immune system. And only then they can become and develop into a clinically evident disease. And this leads to an alarming conclusion that when we, as physicians, see our cancer patients for the first time, the immunological train has already left the station because the immune system has already lost the battle. For a very long time, more than a century actually, we've got it all wrong because we have always thought that cancer arises due to an incompetence of the immune system. And sure enough, all attempts to apply the immunological strategies that work so beautifully against infections, all of these have failed colossally against cancer. But it's no wonder, because unlike an acute infection, the clinically evident cancer has already outplayed the immune system. And in fact, the immune system of the cancer patient isn't necessarily handicapped, because it can efficiently deal with other types of threats, like common cold or flu or whatever. Well, the point is that cancer cells deceive the immune system. They devise stealth mechanisms to evade the lymphocytes. And I personally like to look at it as the biological equivalent of the Klingon cloaking device from Star Trek. Sheer immune boosting is just like getting a bigger gun, but a bigger gun won't help you if you can't see your target. So what are these Klingon-like cloaking mechanisms? The immune system is equipped with internal brakes to avoid the destruction of normal cells. And when these brakes are triggered by specific proteins, lymphocytes are inhibited. Cancer cells hijack these specific proteins to inhibit the lymphocytes and blindfold the immune system. And identification of these proteins has become the focus of the most intensive research, and only few of those have been identified to date. Nevertheless, today it is widely agreed that immune evasion is a fundamental mechanism employed by almost all types of cancer. Now I'm going to get a bit technical, so please try to bear with me. In my research, we have identified a protein that cloaks tumor cells from the immune system, and this protein is called CEACAM1. We stained CEACAM1 with a brownish red color, so it is very easy to appreciate the huge amount of CEACAM1 produced by the tumor, a devastating type of skin cancer, a melanoma in this specific case. Virtually all of the tumor cells produce CEACAM1, and when we zoom in, we can see that the CEACAM1 is found on the cell surface of the cancer cell, effectively cloaking them away from the lymphocytes. And importantly, we observed exactly the same phenomenon in many other types of cancer, such as cancer of the pancreas, the lung, the colon, the bladder, you name it. So how does this cloaking really work? Normally, when a lymphocyte identifies a cancer cell, it becomes activated. And we know how to measure this activation in the lab. When we add in CEACAM1, the activation of the lymphocyte dramatically decreases until complete shutdown. This is the Klingon-like cloaking mechanisms that tumors use to go unnoticed, go unnoticed by the lymphocytes and practically blindfold the immune system. So practically speaking, to treat cancer, we need to deactivate the cloaking device. Because once the cloak is removed, the cancer cell becomes visible again to the immune system. And from there, the lymphocytes, they know what to do best. So you're probably now thinking to yourselves, asking, how can we deactivate these cloaking devices? Well, we thought that the best solution lies in antibodies. Antibodies are products of the immune system, and they can bind to proteins and in many cases even alter their function. Well, we looked for an antibody that binds only to CEACAM1 and thereby neutralizes its cloaking ability, because such an antibody could become a novel drug. Since CEACAM1 is a protein of our own, there are no antibodies against it in our body. So we had to generate antibodies against CEACAM1 in mice. And out of hundreds of antibodies generated in mice, we found one that does the trick. And we engineered it to enable human use and industrial scale production. Now I'm going to show you an example of what it looks like in the lab when we deactivate CEACAM1 with our antibody. These are lungs of mice. On the left, you can see healthy lungs. You can see how pink and smooth they are, especially when you compare it to the right side, where these are lungs that bear huge loads of melanoma metastases. And this is why they appear swollen, lumpy, and black. We treated groups of mice bearing lung melanoma metastases, and while control treatment had no really effect, I would like you to focus and see what happens when we deactivate CEACAM1. The lungs become almost entirely free of melanoma. And importantly, at least in our models, the antibody doesn't drive the immune system to attack the normal cells. And this is unlike chemotherapy, for example, which kills cells indiscriminately. Well, obviously for us, these results were extremely exciting, as you might imagine. And in fact, we're just about to initiate an international clinical trial in cancer patients with this potentially novel drug. And we are optimistic due to the striking results observed in cancer patients with parallel drugs aimed at a different cloaking device, which essentially confirms this entire concept. So for the first time, mankind succeeds in harnessing a 500 million years force of nature in a way that may fit almost all types of cancers and provide strong and durable clinical activity with just little toxicity. Although it is too early to talk about cure for cancer, the immuno-oncology is an important step forward. And actually, it is considered by many to be the biggest revolution in medical oncology since chemotherapy. To me, this entire approach reminds Michelangelo's Prisoners, the famous non finito statues that are still half imprisoned in stone. In his famous quote, Michelangelo said that he sees the statues trapped in the stone and he just liberates them. Well, I like to say that the remedy to cancer, the immune system, is trapped in the cancer. We just need to liberate it. As an oncologist and immunologist, for me, the present is already extremely exciting, and I really can't wait to see how it continues and develops into the future. Thank you.